Today we will see 3 different questions, but all of them dealing with the same premise. This is our first question. What is it about? If a quadrilateral circumscribes a circle, then the sum of its opposite sides is equal. Or in this case, if you consider A, B, C, D, what are the opposite sides? First is AB and CD and the other is AD plus BC. Now their sum, the sum of the opposite sides is equal. That is what we have to prove. Or in other words, if we start with this LHS, we should end at such an result. Then how will we proceed? Now look at this point. You will see that there are 4 points of contact, right? So let us first name them. So the points of the contact, or the places where the quadrilateral meets the circle, we have marked as E, F, G, H. Now let us break down A, B and C, D. How do we do that? You can see that A, B is AE plus EB and CD is what? DG plus GC. And now what do you notice here? If you look at this point A, then you will notice that AH and AE are equal in measure. Why is that? They are 2 tangents from the same external point A to the same circle. Similarly, if you look at the point D, you will notice that DG and DH are equal. Why? They are again points from the same external point D to the same circle. Similarly, you can prove that these 2 parts are equal. Similarly, we can prove that EB and BF are also equal. So what we have is different bits equal to each other. Now why don't we substitute them? Instead of AE, why don't we write AH? And instead of EB, we will write BF, and similarly instead of DG, we will write DH. Do you understand where we are going with this? We are manipulating our statements so that we get AD and BC. We are replacing BC and AB bit by bit, so that instead of those 2 sides, we end up with AD and BC. Are we there? Yes, we are. See, AH and DH together will give you AD, BF and CF will give you BC. Now this is our first question. Now the second question will look different, but it is based on the same logic. Now we move on to our next question. What do we have here? Again a quadrilateral circumscribing a circle. Then what is the result that we just now found out? The sum of the opposite sides are equal. So now, is this any ordinary quadrilateral? No, it is a special one. It is a parallelogram, which means what? Its opposite sides are equal, which means what? AB is equal to CD and BC is equal to AD. Now what do you have to prove? You have to prove that it is a rhombus. What is that one thing which is stopping a parallelogram from becoming a rhombus? In the parallelogram, opposite sides are equal, but for it to become a rhombus, we have to make sure that all the 4 sides are equal to one another. So to prove a parallelogram is a rhombus, won't it be enough to prove that the adjacent sides are equal? So if the adjacent sides are equal, that means all the 4 sides are equal, right? So that is what we are trying to prove here. We have a special kind of a quadrilateral. We have a parallelogram, which means the opposite sides are same, which means instead of AB and CD, we can make them both into 2AB, and instead of 2 different sides of a quadrilateral, we can make it into the same side, which you can choose any side. It won't make any difference. Choose any side you want. So dividing throughout by 2, what do you get? You get AB is equal to AD, which means not just the opposite sides, the adjacent sides are also equal to one another, which means all the 4 sides are equal. Or in other words, it is a rhombus. Now on to our last question. A similar situation. Again a quadrilateral circumscribing a circle. But this time what is the problem? You are given the measurement of 3 sides. You have to find the 4th side. Not a big deal, right? Why? Because the sum of the opposite sides are equal to one another, which means what? You have to find AD. What is AD? It is 6 plus 8 minus 9, which is what? 5 centimeter. That is all for today. Take care. Assalamu alaikum.